Hello, welcome to today's pre-lesson video on quadratic equations and functions. So let's get started right ahead. So as you learned before, when it comes to like trinomials or essentially quadratic equations, we could use one method to find the solution or the x-intercepts, which is the butterfly method that we learned before. Now the other method that you could use is with the quadratic formula. And now as you can see, right, quadratic equations are given by ax squared plus bx plus c equals 0. When you're given this, then you can use the quadratic formula, which is given as this. It is x equals negative b plus minus square root b squared minus 4ac, all of that divided by 2. Now, we are going to see how we're going to use the quadratic formula to find the solution of the quadratic equation in this question. So we're given 2x squared minus 5x plus 1 equals 0. I'm going to first list out what my a, b, and c are. So as you can see here, if we list it out, right, my a is going to be 2, my b is negative 5, and my c is 1. Now if I were to plug that into the quadratic equation, I'll get negative times negative 5 plus minus square root negative 5 squared minus 4 times 2 times 1. All of this divided by 2 times 2. All right. Now from here, I'm going to simplify what I can. So negative times negative 5 is going to give me 5, positive 5, plus minus 25 minus 8 over 4. Right. Now from here, I'm going to solve inside the square root. So it's going to give me 5 plus minus square root 17 over 4. Right. And now because I know that square root 17 is not going to give me a perfect square, I'm just going to leave it as it is. Therefore, technically this is my answer. If I want to split it up, I have two solutions because of the plus minus sign. So essentially I have x equals to 5 plus square root 17 divided by 4, or x equals to 5 minus square root 17 divided by 4 as my solutions. All right, so as you can see, I have two solutions for this quadratic equation. And this is how you would use the quadratic formula to find the solutions, because sometimes you just can't use the butterfly method even after trying a few combinations, and so you would then need to use the quadratic formula. Now, a good way to tell if you need to use a quadratic formula, especially if it's in a multiple choice setting, is the answer options they give you. Right? If the answer options they give you as a decimal or as a in like square root form like this, then you want to straight away just use the quadratic formula. All right. So now let's look at another question. Again, as usual, I'm going to list out my a, b, and c first. So I know my a here is 15, my b is negative 1, and my c is negative 2. Again, I'm going to plug this all in according to how the formula is. So I get x equals negative times negative 1 plus minus square root negative 1 squared minus 4 times 15 times negative 2. All right. Divided by 2 times 15. Now this, as I simplify everything, is going to give me 1 plus minus 1 plus 120, there we go, divided by 30. All right, group the like terms in the square root, we get 1 plus minus 121 divided by 30. Now I know that 121 is a perfect square, so let me go ahead and square root that to give me 11 divided by 30. Now to find the exact values, I'm going to split this into two equations. So I have x equals 1 plus 11 over 30, or x equals 1 minus 11 over 30, right? And now I'm going to go ahead and solve it completely. So here for x equals 1 plus 11 over 30, I'm going to get x equals 2 over 5 as one of my solutions. And on x equals 1 minus 11 divided by 30, I am going to get x equals negative 1 over 3. And this is my other solution. All right. So as you can see with the previous question, we would get our solution in terms of like a square root just because we could not simplify it further. And sometimes you can simplify it further, like in this case, right? We get a like number that's not in the square root. So this is how you would be able to solve the solution, find the solutions in a quadratic equation by using the quadratic formula. All right. So it is really handy to memorize this formula. Okay. Now on to the next thing, graphing quadratic equations. So as you can see, this is the parent function or the original function for a quadratic equation. It will be a smiley face, as you can see this turning up like a smile, right? And your vertex will be at 0, 0, right? So vertex will be like the highest or like the turning point of the graph. Now, in order to graph a quadratic equation, it is really handy to know what the vertex is. And to find out what the vertex of the where the vertex of the equation is, you would use x equals negative b over 2a based on the quadratic equation that you're given. All right, so we'll actually see this how we're going to do it in a second. Now, once you find what the vertex is, you're going to choose two values of x that are on both sides of your vertex, on the left and on the right. So, for example, if your vertex is at, say, this is 4, 2, then you want to pick two values that are on the left, as you can see. So, like, you'll pick 3 and 2. And after that, you want to find its coordinates, right? So you're going to plug in the values of x into your equation to find its y value to get the coordinates. Once you've done on the left, then you could pick another two values that are on the right, plug that in into the equation to find their y coordinates, and then you get another 2 points. All right. Once you have at least 3, better 5, then you can draw your curve passing through all of these points. All right. So try to draw as smooth as possible that passes through all these 5 points for your quadratic equation. Now on the SAT and ACT test, you do not need to graph the equation itself, but it is pretty handy to know how it's done. Okay. Now let's look at this example question. We have y equals x squared minus x minus 2. So let's look. I know my a is 1, my b is negative 1, and my c is negative 2. So I want to find a vertex, so I'm going to use x equals negative b over 2a to find its coordinates. So the x coordinates of my vertex is going to be, let's see if I plug in all the values, it is going to be half. All right. Now, I know when x is half, my y is going to be, let's see, so now I'm plugging in the x, substituting the x with half in the equation that we're given, all right, to find a y coordinate. So when x is half, my y is going to be negative 9 over 4. This means my vertex is at half negative 9 over 4, all right? Now, the next thing I want to do is sometimes you could also just find the x-intercepts to find 2 points that are on either sides of the vertex. That will help you get points. All right, so I'm going to go ahead and do the butterfly method, which will give me 1, negative 2, negative 1. Let's see. There we go, this works. So we factor it, we get x minus 2, x plus 1 equals 0. And then to find the points, we would do this to find the coordinates of the x-intercepts. All right. So now x is 2 and x is -1, which then tells me that my coordinates are going to be 2, 0 and -1, 0. So now we have 1 point on each side of the vertex. So now we're going to pick another 2 numbers that are on other sides of the vertex so that we have more points to graph. All right, so let's say when x is 1, my y is going to be, let's look, my y is going to be -2. So that gives me the coordinates of 1, -2. And when x is 0, let's look, that is going to give me the y coordinates of y is -2. So that means my other coordinates are going to be 0, -2. All right. So now from all this, it tells me that my points on my graph are going to be -1, 0, 0, -2, half, -9/4, 1, -2, and 2, 0. Now from here, I can roughly plot my graph. So let me just rough sketch from here. Let's look. We have about, this is going to be -1, 0. This is going to be 0, -2. Right here is about our vertex, which is half, -9/4. Right here is our other point, which is 1, -2. And then right here is our other x-intercept, which is 2, 0. And now I'm just going to roughly sketch it. So it should look like this, passing through all those points. All right, as you can see. So then this gives us y equals x squared minus x minus 2. And so this is the graph of the quadratic equation. All right, if you have any questions about how to graph a quadratic equation, bring it to your deep dive lesson or shoot me a message. Okay, now on to the next thing is understanding the vertex form. So essentially, quadratic equations can be written in vertex form, which tells you where the vertex is, right? So if you look, your a here is going to be the same a value that you get in ax squared plus bx plus c, okay? And then h here is going to be your x coordinate of your vertex. And then your k is going to be the y coordinate of the vertex. All right. So essentially, based on this, we can tell that the coordinates of the vertex is going to be hk. All right. Now with a, all right, if a is positive, let me write that again. If you have a positive a, then your graph is going to open upwards like a smiley face. If you have a negative a, then it's going to open downwards like a frowny face, right? Now, if your value of a is smaller than 1, then your graph will widen, or it stretches sideways like a really wide smiley face like this. And now if your value of a is bigger than 1, right, it will narrow, so it'll be like really thin like this. Can you see? So it's just really handy to remember, at least for the positive and negative a, how they will look like. All right, if you have any questions about this, bring it to your D-type lesson. Now let's look. So we want to write the following function in vertex form, right? So in order to find the vertex, again, we would want to use x equals -b/2a, because this actually straight away tells us what the turning point, which is essentially the vertex of the equation, right? So from here, I know that my b is going to be -8 and my a is going to be 1. So we're going to plug that all in, and all this should give us, let's see, 8/2. So my x coordinate of my vertex is going to be 4, all right? And now when x is 4, based on this function, right, we would plug it all in, our y value is going to be, let's look, -25. So that means our vertex is going to be at 4, -25, right? So essentially also, this tells us our h and this tells us our k. Now we need a. So a, like I say, is the same thing like you get in your equation. So straight away I know my a is going to be 1. Therefore, if I were to write this function as in vertex form, I would get f(x) equals to x minus 4 squared minus 25. All right. As you can see, this is my h and this is my k. And my a is also right there. Technically, it's 1, so we don't need to write it. All right. And that's how you would write your quadratic equation in vertex form. Now we look this. If we want to graph our quadratic equations in vertex form, it is pretty handy if we're given this and we transform it into a quadratic equation, because we are given, a turning point, and so we know which two values to pick on the left and which two values to pick on the right. So let's find our equation in vertex form. So we have x equals -b/2a. Let's plug in all the values that we're given. So again, we get 4. So our h is 4. And now when x is 4, our y value is going to be, let's look. Okay. So that means my vertex is going to be at 4, 5, which gives me my equation in vertex form as x minus 4 squared plus 5. All right, now from here, I'm going to pick 2 other points that are on the left of my vertex and on the right of my vertex. Okay, so let's look. Let's do my left first. So when x is 3, I plug everything in. Let's look. What's 5? This would give me 6. So one of my coordinates is going to be 3, 6. Now for the other value that's on the left, let's pick 0. Alright, so when x is 0, I am going to get 21. So my other point that I know is 0, 21. Now when x is 5, this is going to give me 6. So my other coordinate is 5, 6. And then let's see, when x is 6, I am going to get 6, 9. Okay, so now that I have 5 points for my graph, I can plot my quadratic equation. All right. So let me just roughly draw this out. So now you'll see a big reason why we didn't use the x-intercept to find it in a second, which is why sometimes it's not reliable to try to find the x-intercept to graph. It's just easier to find a vertex and then pick 2 points that are on the left, 2 values of x that are on the left of the vertex, and then 2 values of x that are on the right of the vertex. All right, so let's look. We have, say, what's this, 0, 21. This is 3, 6. This is 4, 5. This one is 5, 6. And then this is 6, 9. Now if we were to sketch it roughly, passes through all the points. There we go. Alright. So this will be our function. Alright, so now a big reason that we did not find an x-intercept to take as points is because it doesn't have any x-intercepts. As you can see, the graph does not cross the x-axis, so we wouldn't be able to find the x-intercepts because it doesn't have any. Now, in a second when we get into here, we're going to see why we wouldn't use that and how it's actually really handy to know how to graph, alright? So now, before that, we're going to learn a little bit about like quadratic functions, and the transformations. And actually, these transformations apply to any kind of function. So it's just really, really handy to know the rules, especially the first 6. All right, so like these ones are really handy to remember. So fx, without anything being changed, is the original function, right? Now we look here. If we have fx plus a, so as you can see, the a here is outside of the x, we're going to move the function up, right? Now, if we have fx minus a, like this one, where the a is outside of the x, we're going to move it down. So we move it according to sides, a plus a being going up and minus a being moving down. Now, if you look at this one, we have fx plus a with the a inside of the x, in the parentheses with the x, right? So when the number is inside with the inside parentheses with the x, we're going to move it left and right. Now, here's the thing you need to remember. If it's in the parentheses with x, you're going to move it in the opposite direction of its sign. So if it shows like an x plus a, like this one here, we're actually going to move it to the left, right? So if it shows like fx plus 4, that means we're going to move the original graph, the parent function, right, the parent graph, 4 units to the left. Now, if it's fx minus a, with the a in the parentheses with the x, like here, we're going to move it a amount of units to the right, right? Because it's a negative a, we're going to do the opposite. We're going to move it to the right, all right? And then these 4 are the most common ones and really handy to remember. Now, these ones are a lot less common, but it is, it'll be really good if you remember, but at least remember for these 4. All right, so now if we have negative fx, what this means is that it's going to reflect vertically. So vertically would be this way, all right, over the x-axis. So it'll go from top to bottom, all right, it'll be flip-flop. So if, let's say your parent function is this, then this would make it a frowny, okay? And then if the negative, so it's f negative x, then your fx is going to reflect it horizontally over the y-axis. So it's going to go from left to right. So let's say it was originally, this was the parent function, then let's say this was the original. That means this would be the translation, all right? If you have any questions about this one, then bring it to your deep dive lesson or shoot me a message. All right, and now if your a, right, so if your a in front of the fx is between 0 and 1, that means it is going to go through a vertical compression. If it's more than 1, it'll go to a vertical expansion. And if the a is with the x and it's between 0 and 1, it's going to go through a horizontal compression. And if it's bigger than 1, it will go to a horizontal expansion. So this one isn't, in my opinion, it isn't that much to worry about just because it is less common. Like I say, these 4 are the most common ones and be really, really good for you to remember. These ones are just handy, with this specific one, negative fx, appearing more often than this. But yes, definitely the first 4, do remember. Now let's look at this question of how we're going to find the equation of the function after the translation. So if fx equals x squared minus 5x plus 7. What is f? What is f? X plus 2 minus 4, right? So from here I can tell that my graph is 1 because of this. It's going to move 2 units to the left. And because of this, it's going to move 4 units down. All right, now to find the function after the translation, let's look. So we have our parent function is this. So we're now going to insert it. So we are going to replace x that's in a function with x plus 2. So we're going to get x plus 2 square minus 5 times x plus 2 plus 7. And because we have a minus 4 outside, we're just going to add the minus 4 here. All right. Now from here, we're going to distribute the parentheses to give us x squared plus 4x plus 4 minus 5x minus 10, and 7 plus 4 will give us 3. Group all the like terms, we'll get x squared minus x minus 3. And so this would be the function of our, this will be the equation of our function after the translation. Now to see how it looks like from the translation. So this is the original fx. We just roughly sketch it. All right. So our original fx would look like this. All right. So this is fx equals x squared minus 5x plus 7. And now after the translation, which I know it moves 2 units left because of the x plus 2, and 4 units down because of the minus 4, it will now look like this if I roughly sketch it. So it moves 2 units down, 2 units left, 4 units down. See how it slightly changes there? Right. Then actually this would be translation. There we go. And so this would be f. Our function would be x plus 2 minus 4. So this would be x squared minus x minus 3. Here we go. All right. So that's how it translates. If you have any questions about this, bring it to your deep dive lesson. All right. Now on to the very last thing. So when solving for quadratic equations by graphing, it's really handy if you're able to graph because you can instantly tell sometimes where your answer is, right? So as you can see here, normally when it says, if they give you a graph and they ask you for the solution, right? If you actually notice, your solutions will be where the x-intercepts are. So wherever it intercepts will be your solution to your graph. So in this case, the solution would be x is 1 and x is 5, and those are the solutions, right? So it's really handy if you can graph. Now, what if we look at this one before, right? See how it does not, how the graph does not intercept with the x-axis? That means it has no real solution. And when it has no real solution, technically it can still factor, but your answer, your solution will be in terms of an imaginary number. It will be in terms of I. Okay, so if it doesn't intercept the x-intercept, it will have no real solution. It will have imaginary solutions in terms of I. Okay. Now, a really handy thing also with being able to graph is, one, you can tell what the vertex is. So as you can see, the vertex is the turning point in this case, which we'll use with x equals negative b over 2a. Along those lines, if you also want to find the axis of symmetry, right, where it splits the graph in half, again, you would use x equals negative b over 2a to find the axis of symmetry. All right, so it's really, really handy if you're able to graph the equation, if you're able to graph the quadratic equation. All right, and so this is it for your pre-lesson video on quadratic equations and functions. Again, as usual, if you have any questions about it, bring it to your deep dive lesson or shoot me a message. All right, have a good rest of your day.